Okay. Quickly, what we did yesterday in the last class was this. Xn was a sequence, finite length, capital N point, Hn was a finite length sequence. If you take DTFTs and if you multiply the two DTFTs, then they correspond to a sequence in the time domain which is a convolution between linear convolution between Xn and Hn. That is, multiplication in frequency domain is convolution in time domain, they are equivalent. Suppose in the DFT domain I do the same thing. I take the samples of this DTFT, kth sample is kth DFT, capital Xk, we have already seen. I take kth sample of this DTFT, that will be Hk. So, I again multiply them. Okay. Then if I take, and how many I get? If I multiply them, I call it capital Yk. How many? For k equal to 0 to n minus 1. So, I take n point inverse DFT and I get a length n sequence now Yn. How will Yn be related to Xn and Hn? Will that be linear convolution? Answer is no. Then what it is? For that, we carried out this job. Capital Xk was just DFT of Xn. So, this is XL, we are using the index L here, L 0 to n minus 1, XL e to the power minus j 2 pi kl by n. Similarly, capital Hk is small m 0 to capital N minus 1, h small m e to the power minus j 2 pi k m by n. They are standard. Yn is the inverse DFT of Yk, Yk is the product. So, we run the inverse DFT at an index small n which is fixed here from outside. So, this k equal to 0 to n minus 1, this product e to the power j 2 pi k small n coming from outside, then capital N by capital N and summed over small k. This is the standard inverse DFT formula. Then capital Xk I replaced by this DFT formula, Hk I replaced by this DFT formula, I get a triple sum. I interchange the order of summation, I bring the outermost summation to the inside. If I do that, what I get is this 1 by n, xl remains outside with respect to L, hm remains here in the next summation with respect to m, but the three exponentials contain k and the inner summation is now with respect to k. So, all of them come together. So, you have got this n minus m minus l, n is fixed from outside, but n is also in this range, okay, within that range only, m from this summation from the same range, l from this summation from the same range. So, n integer, m integer, l integer, so their difference n minus m minus l is an integer, I call it p. Suppose p is 0, then e to the power 0, 1, 1, 1, 1, if you add, you get capital N and 1 by n cancels, you get this summation. Or suppose p is capital N or minus capital N or 2 capital N, minus 2 capital N, every time n and n will cancel, so it will be e to the power j 2 pi into an integer. So, there is 1 and we get 1, 1, 1 added, that is capital N, that will cancel with this. So, under this case, when this is an integer, I get some value, but suppose it is not, n minus m minus l is neither 0 nor an integer times or times capital N. So, p if I divide by capital N, I do not get an integer r. In that case, this summation becomes what is GP series e to the power j 2 pi k p by n and it is in terms of k. So, bring e to the power j 2 pi p by n inside and call it small a. So, a to the power k from 0 to n minus 1. So, if you run the GP series, it is 1 minus a to the power n capital N by 1 minus a. By substitution, it is 1 minus e to the power j 2 pi p, n n cancels and 1 minus e to the power j 2 pi p by n. Now, this is 1 e to the power j 2 pi p because p is an integer. So, 1 minus 1 is 0. In the denominator, p by capital N is cannot be an integer from here. This is not under this case. P by n here was integer r, but here is not integer. So, p by n if it is not an integer, e to the power j 2 pi into some fraction, that cannot be 1, which means denominator cannot be 1 minus 1 0. So, numerator 0, denominator non-zero, you get 0. So, these cases will go out because the reality is 0. Only these cases will have to be considered. In that case, what is the summation? Summation n and n cancelled, summation is Yn is this outer summation xl, inner summation hm, okay, and that is all, n and n cancelled, but not all L, all M will be considered, only these cases, this case will be considered, that is only that M and that L will be considered, okay, for which this is satisfied. So, then we drew two lines, one for M, one for L over the same range 0 to n minus 1, 0 to n minus 1, and suppose we start like this and your small n, you have to find a good y at small n, that is somewhere here in this range, suppose it is here. So, start with L equal to 0, x 0, then if you put 0 here, n minus m must be equal to either 0 or plus n minus n dot 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 dot. Suppose you start with 0, so then m will be small n, which is fine because small n is within the range of m. But if you put capital M here, then it will small m will be n minus n. This is outside this range for small m, because if you small n is here, capital N minus 1, if you subtract n from it, you are here outside. If you put minus capital N here, then m will be n plus capital N. So, again it is outside the range, even if n is small 0, if you add capital N to it, you are outside. So, those values we are not considering. So, therefore, m is in this case just n. That is why in this summation, when you have got x 0, you have got h n, then x 1, L is 1, if you put 1 here, n minus 1, if it is 0, m will be n minus 1. By the same logic, you cannot have capital N minus n all those here, because it will be out of the range. You can verify. So, x 1, and we have done it yesterday. So, x 1 h n minus 1, okay, because if m is L is 1, n minus 1, n minus m minus 1, if you take it to be 0, m is n minus 1. Okay. If you take this to be capital N, m will be n minus 1 minus capital N, which is further outside the range. Okay. So, this if you take to be plus capital N minus capital N, it will be this. Again it will be further outside the range. All right. So, you cannot do that. Okay. So, this is the range. All right. And then it goes on x L h 0, when L, it is not x L, it is x n, sorry. When L takes the value n here, okay, so it is when I am 0, this is n, when it is 1, n minus 1, when it is 2, n minus 2, dot dot dot, when it is n, it becomes 0. So, h is 0, when it is n, it is 0, 0 n, 1 n minus 1, 2 n minus 2, n 0. Then when L becomes n plus 1, what should be m? Now, n plus 1, we have seen yesterday, n plus 1, if L is n plus 1, it is n, so you have got minus m minus 1. If you equate that to be 0, m is minus 1, m is here, minus 1, but that is not allowed. But in this case, if instead of taking this to be 0, taking this to be 0, we take it to be n, say minus n, because r into n. So, 0 is possible, plus n possible, minus n possible. So, if I put minus n, then m is capital N minus 1, which is within this range. So, we will take this, okay. No other value is possible. So, n minus 1, that is why it is becoming n minus 1, what is small n plus 1. Then if it is small n plus 2, then n and minus n minus 2. So, m is, it will become minus m minus 2, and you, this is the only choice. So, you take m becomes capital N minus 2, that is why n minus 2, and dot 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 dot, finally, when it is becoming capital N minus 1, it is becoming small n plus 1. If you add the two indices, you see small n plus capital N, 1 and minus 1 cancels, small n plus capital N, 2 minus 2 cancels, like that. Now, this whole summation is actually different from linear convolution. We will see that this component is actually linear convolution between x n and h n, but not this. Because of the presence of this, the whole thing is different. So, from y n, I cannot get linear convolution. Why this is linear convolution? If you have two sequences, say x 0, x 1 dot 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 dot, say x n minus 1, okay, in terms of say r, and you have another sequence h 0, h 1 dot 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 dot, say h n minus 1 in terms of L, in terms of again r. How do we convolve graphically? We hold this sequence as it is, as a function of r, you flip it, and if you start giving shift. So, if you flip it, And suppose I want to find out the convolution at an index n is from 0 to capital N minus 1. So, I have to shift it by n. So, H0, if you flip it, H0, H1, H2 dot dot on this side, and this side becomes 0. There is zeros from left come over here. It is like this, H0, H1 dot 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 and zeros on this side. Okay. Then you shift to the right by small n. So, H of 0 comes here. Okay. Then H of 1 at n minus 1 dot 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 dot, here it will be H n at 0, nth point H 0, n minus 1th 1th, okay, n minus 2 H 2, 0 means n minus n, so it is H n. So, if I now convolve, that means I have to multiply this with this. So, nth point this sequence has x n. So, x n into H 0, you see x n into H 0, all right. Then will be x n minus 1 into H 1, previous term will be x n minus 1 H 1, this is x n minus 1 H 1 dot 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 dot. Then here x 0 H n, x 0 H n, here H 1, sorry, here x 1 H n minus 1, right, H 0 H 1 dot 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 H n minus 1 H n. So, you see, so you get linear convolution evaluated at an index n, this part, but this part is not. So, but final result is coming as a summation of the two. Within the summation, this is hidden. I want to extract this linear convolution from y n, but I cannot, because it is coming as a summation of the two. So, how to, what should we do so that this I can extract? That is the next question. But before doing that, we should understand the graphical procedure of carrying out this convolution. This is called, this overall thing is called circular convolution. Okay, let us give a graphical interpretation of this. Then we will proceed for a technique by which the linear convolution part can be extracted. So, suppose, so remember this is my expression, this plus this. Okay. How to calculate graphically, I am showing you. Earlier I have shown graphical way of doing linear convolution. Now, I will show graphical way of doing circular convolution, that is this whole summation. So, suppose you got two sequences, then the rule is hold number one sequence as it is, x 0 same length, okay, maybe as a function of r, and other sequence which you have, you make it periodic. That is, if it is given like this h 0, then h 1 dot 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 h n minus 1, you make this periodic, that is, you add further repetition, again same h 0, again same h 1. So, h 0 comes at nth point, this is at n plus 1th point dot 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 up to here, okay, n minus 1. So, this will be 2 n minus 1, this is another period. Similarly, on this side again you add another period. Okay. If it is 0, 0 into plus n, now 0 will go to minus n, again here the same h 0, same h 1, this is at minus n plus 1 dot 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 here, same h n minus 1. So, this is one period, this is one period, this is one period dot 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 dot, you make it periodic. So, I am telling you the rules. If you are doing circular convolution between two sequences graphically, I am suggesting a rule and then we will verify, that will give you this expression. So, what is the rule? One of the sequences you hold as it is, as a function of r, not n, because you want to find out the convolution at a fixed small n. So, make it a function of variable r. At the other sequence also you make it a function of r, but if it is one period is given from 0 to n minus 1, you repeat it again. So, one block, same block again, so you get a periodic sequence. So, this is step number 2. Step number 1, hold first sequence as a function of r. Step number 2, make the other sequence as a periodic sequence. This is periodic repetition of that block as a function of r. Then third step is flip this periodic sequence. That is, from right side it goes to left side and left side goes to right side. Okay. So, your flipping means H0 will remain here, this H1 will go here, dot 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 n minus 1. So, at minus n minus 1 this guy will go, then at minus n this H0 will go, dot 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 dot. Okay. And on this side, H capital N minus 1, from left it will go here, okay. This goes here, like that. Point number 1 goes to minus 1, minus 1 thing goes to plus 1. At plus 2 whatever it was, it goes to minus 2, minus 2 whatever it was goes to plus 2. This is called flipping. Right side gets over to left hand side gets over to right hand side. So, here these were minus 1, minus 2 like that. So, at 1 H n minus 1 will come, then at 2 H n minus 2 will come, dot 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 dot. At n minus 1 who will come, whichever was at minus n plus 1, that is this H1. Okay. Capital N minus 1 will go to this place, minus n plus 1, and from minus n plus 1 H1 will come, and then dot 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 dot. I do not need them. Okay. You can find out what is the flip sequence. So, first step, hold one sequence as it is as a function of power. Second step, other sequence you make it periodic as a function of power. Third step, flip this periodic sequence, right side goes to left, left side goes to right. Fourth step, now shift this periodic sequence to the right by n. N is what? N is the point where you want to find out y n. N can be in the same range. Okay, in the previous summation we found y n equal to this for a n of our choice in this range. So, if you want to find out y n for a particular n in this range, then just shift this flipped periodic sequence to the right by n. And then you multiply sample wise this sequence with this sequence, and obviously outside this window no need to consider because we have got 0 values. So, from the other sequence whatever is the sample that will get multiplied from here by 0. So, they do not contribute anything. So, we will only consider everything which falls directly under this window from 0 to n minus 1. So, if you now flip it, I am writing here, after flipping, shifting by n, it is H0, H0 will go to Hn, nth point, here H0 will move, after n shift, one shift H0 will come here, two shift it will come here, n shift it will come here, then it will be followed by H1, dot 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 dot, then H2, dot 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 dot. So, at nth index H0, n minus 1th index H1, n minus 2th index H2, at 0th index there is n minus n, H small n will come. From this side H0, H1, H2, Hn is here, this is at minus n. Okay. It was first on this side at plus n, after flipping it went at minus n. So, everybody is getting shifted to the right by n, H0 moved to nth point, H1 moved to n minus 1th point from here from minus 1 to n minus 1. Hn from minus n it will shift to the right by plus n. So, plus n and minus n 0. So, Hn will sit here, come here, dot 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 dot, and H0 before that I have Hn minus 1. So, Hn minus 1 will be here, this guy, then this guy at n plus 2 dot 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 at n minus 1 who will go? Capital N minus 1 came at small n plus 1. capital N minus 2 at small n plus 2. You see, if you add these two indices, it is small n plus capital N. It is small n plus 2, capital N minus 2, again small n plus capital N, 2 minus 2 cancels. So, if it is capital N minus 1, this should be capital N plus 1, sorry, small n plus 1. So, if you add the 2, again 1 minus 1 cancels, capital N plus n. This is how to remember. Small n plus 1, capital N minus 1. If you add the 2, small n plus capital N. Here also, n plus 2, capital N minus 2. If you add the 2, small n plus capital N. Here also, capital N minus 1, small n plus 1. If you add the 2, small n plus capital. Okay. Now, and to the right I have some value left, but this is a range of interest, because now I will be multiplying this with this sequence. This sequence. This has non-zero value only over 0 to n minus 1. That is why 0 to n minus 1 will matter. And what will you get? Consider this black ink, black color samples. Okay. H0, it is at nth point. So, nth point I have got x n, H1 at n minus 1. This is original normal sequence, it was x n minus 1, dot 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 h n x 0. So, if you do this black sample versus black sample, what you get is that linear convolution part. Okay. That is H sequence shifted, I mean flipped, as though, okay, this thing, x as it is, H was say shifted and then flipped, H was flipped like this, H0, H1, H2, and then brought back here, that is shifted to the right by n. So, H0 comes at nth point, H0 comes at nth point, then H1 up to Hn. So, this, if I consider black samples versus black samples here, okay, only this part if you multiply, that is H0 into Xn, H1 into Xn minus 1, dot 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 Hn X0, that is only this part. Okay. Remaining part I will do, but only this part I am doing separately. That is same as what we had here. You see, if you are doing linear convolution, x sequence was, xn sequence was plotted as R, H sequence was plotted as R, then flipped. Flipped means H0 here, then H1, H2 dot dot dot. Then if you shift it to the right by n, H0 from 0th location goes to nth location, H1 from minus 1th location goes to n minus 1th location, dot dot dot. Okay, Hn from minus nth location goes to 0th location. Then if you multiply these two, you will get, you see, H0 xn, same here, H0 xn. Then H1 xn minus 1, H1 xn minus 1, dot dot dot, Hn x0, Hn x0. Okay. So, that part you get the linear convolution part, that is H0 xn plus H1 dot dot H n x 0. This part is the linear convolution, and what you get after that? After that you get H n minus 1, and at what point? Small n plus 1th point. So, sample value is x, this is x n plus 1, because this index is n plus 1. So, this into this. So, at n plus 1th index I have got x small n plus 1, and here I have got h capital N minus 1. So, h capital N minus 1 into from here x n plus 1. Then next index I have got h n minus 2, that is small n plus 2 index. That time I will have h at small n plus 2. So, h small n plus 2 and dot dot dot. Finally, at capital N minus 1 index h small n plus 1, and that time I have got the last sample x n minus 1. You see, this is what we have in the circular convolution expression. This is that linear convolution x 0 h n, x 0 h n, dot 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 x n h 0, x n h 0 is just written in reverse way. That part is a linear convolution, and then you have got h capital N minus 1, x small n plus 1, h capital N minus 1, small x small n plus 1. Then h capital N minus 2, this is x, sorry, x small n plus 2, dot 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 h small n plus 1, h small n plus 1, x capital N minus 1, x capital, you see. So, this is the graphical interpretation of circular convolution. All right. We can use this technique. So, I repeat again, you hold the original one sequence as it is as a function of r, make the other sequence periodic by repeating that block 0 to capital N minus 1 again. Okay. And then third step is flip it. So, right side goes to left, left side goes to right, nth point goes to minus 1th point, minus nth point, minus nth comes to nth. There is sample at nth point goes now to minus nth point, and minus nth point whatever sample it was, now it has comes to nth point. So, flipped. And now you want to carry out the convolution, circular convolution at an index n within that range. So, within the range of that sequence, 0 to capital N minus 1, this is my final range. So, shift this flipped periodic sequence to the right by that small n. Okay. And if you do that, and then whatever comes under this block of that first sequence, you hold that only and then multiply sample wise. Okay. Other terms of this flipped sequence are not consideration or of no consideration, because they will get multiplied from 0 from this first sequence, because outside this block this original first sequence has only 0 values. So, if you try to multiply all the samples of this shifted flipped periodic sequence by the corresponding samples of this original first sequence, outside this window there is no point in carrying out this multiplication, because this first sequence has 0 values only outside this window. That is why we will consider this product sample wise and addition only from 0 to a capital N minus 1. And if you do that and sum, you get 2, out of which you have got the linear convolution part and you have got the circular convolution part. In the next class, I will show you a technique by which we can find out linear convolution out of circular convolution using this graphical business. Okay. So, that is all for today. Thank you very much.